I'm Horatio from BMWBlog.
And I'm Sean for Precision Sport Industries.
And we're here today in Slovenia near Ljubljana to visit Akrapovič.
And today we're going to dive into how these amazing exhausts are constructed. We're going to get into the design, the R&D, the engineering, and also we're going to show you guys the testing on the dyno.
Hello, my name is Robert. We are now in the lab for material testing. What we do here is test material, special alloys, a lot work on titanium. So we do 100% control of special titanium alloys that Akrapovič use, so it's not the standard one. So we must be sure that incoming material is good. Then we do a lot of examination for the casting facility. So we check daily material from the castings. And we do a lot of quality checks for production. So it means that we cut the part, extract the weld, cut it perpendicularly, and we check if the strip and welds are okay. So we can see here clearly the penetration in the material, width, height of the weld, minimum thickness, and so on. So with this kind of analysis, we can confirm the welding parameters, assembly before welding and after the welding is okay.
What's your biggest challenge when you usually do this? Like if you were like to look at all these welding materials like every day, what's your biggest
time
challenge?
window. Normally
The time
there's
window.
a lot of samples and we need to hurry because then production gets the green light to continue to weld.
So if it does not pass, let's say, what is the process? Does it get set aside and then?
Then we take another sample, check if this is normally if you have a round part, if this is a problem on I don't know three places, then it's not okay. And in this case we stop. We say okay, this is not okay on this part is critical, and we will do something in production, assembly, change welding parameters, so on, and repeat the test.
So maybe like during the welding
More
process,
parts.
the material moved or had movement or changed the shape. You guys would find that here.
Yes, but the problem with this is that you destroy the sample, no? the
Gotcha.
part. No?
Yeah.
So normally it's okay, and you just confirm the welding parameters are okay, but we do regular checking. I don't know, every 100 part, still we check, because maybe welder is different and so
Maybe
on.
something changed.
That we are sure that this is continuously okay. Here is a simple hardness test. So we measure how hard is the material from our casting facility. So every melt is being checked with chemical composition, a fast hardness measurement, and also with tensile testing. So in this case, this is Brinell hardness test. We just measure how hard is material. If it's too hard, can be brittle, is not okay. If too soft, it's constructionally not okay. So this fast test confirmed that everything is okay with material.
So now we are in the measuring department, which is quite important department for us in our process, because here we check what we do. We measure the jigs, tools, and also parts. So in this case, let's say we have a measuring size machine, which is now measuring a part. So this is from our, let's say, from the newer generation of M3, M4, and also M2. And we are actually checking, what we were able to do in production and if it's according to technical documentation, so control drawings. This step is important for us because we know what we are delivering to the market, right? On the other hand, we are also checking the jigs and tools in order to get to the CAD models or to the, let's say, what we want to achieve with the parts according to the CAD models. Some of the jigs and some of the tools are differently shaped as the part itself because of the behavior of material during the process. But the main focus is that whatever we do in the computer environment, we check in let's say in reality. That's the main purpose of this department. In some cases, we have 100% quality check, which means that the parts which we are delivering to the market, to the OEM customers or whatever, are 100% each by each. For that, we have also some other tools which we'll see later on.
How early do you start the process? So let's say that you know that there is an M3 and M4 coming, but we don't have the car and all of that. Like, do you work with OEMs basically to get some advanced information on what you can produce, or that you have to just figure out?
I mean, it depends on the type of the project, right?
Okay.
If it's the OEM project, it depends again where we step in the development process. But in most cases, we have like 1 to 1.5 years of, let's say, managing the project, which means that as early we can get into the project, as much as information we can get, and to also work with that, also with them, right? In aftermarket case, it depends on the vehicle coming. So when we start with the scanning process, because we want to do everything in a computer environment in order to do also all the simulations theoretically first, and then do the CAD model, which is the reference for the complete production afterwards. So it kind of really depends where we step in. In racing, let's say, it's also very important, and the timeline is, of course, sporty, usually. But again, it depends, you know, where we are.
So is this process in part of the beginning? Say you would make the complete M4 system, test it here to verify the jigs and the material, and then it goes to a quicker production, or are you pulling samples off the assembly line to then measure?
I think it depends on which phase of the process we are looking at. In the development phase, the main focus is the product development, which means that in the end we need to come up with the NVH sample, which we confirm, which is signed off. And then the most important, let's say, role of the measuring department is in the technological phase and production phase, where we check first of all the jigs, right? And then the parts which come off the jig, which we call a pre-series production. So those samples are checked. Usually we manufacture 3 of them, check them on the car, depending also on the measuring reports, because we check the worst sample according to the control drawing and the best sample. And then we can see where we are with the tolerances.
And that's when you would make the revisions to the jig, so to speak. If material's moving or if something's happening in production, that's found here, and then those changes are made.
Exactly. That's in the technological phase.
Before production.
Before production. Before the zero production, which is the first serial production in the production process. And then at that time, of course, we also measure, in many cases, the products from the serial production, which are actually off serial, off tool parts and off serial. So off tool, off serial process.
For the aftermarket, do you race to be the first out there with a product, or do you strive for being the best?
Both.
Both. Okay, so it's quite important to be quite fast to the market, basically.
It is. Time to market is actually one of our factors, which is, or according to which we are also, let's say, aiming or judging how the project was successful at our company. So it is very important also from the sales perspective, of course.
Perfect. Thank you.
Thank you. So now we are standing in front of our scan box, so Atos scan box. So this is a measuring cell. It's here in headquarters. We have one scan box, but actually we have also one in production. And the main focus here in this site is that we, in some cases where we have the small production, small volume of products, we check them here. So the quality control check is done by a scanning device. And here we check this product according to the control drawing or according to the CAD model. It depends what we want to achieve. And then we evaluate the discrepancies, maybe change some things in production, you know, like jigs, some way of manufacturing or assembly. Or on the other hand, we just check whether the part is according to the control drawing and ready to be dispatched to the market. On the other hand, in the serial production, we have the measuring device, scan box, which actually do the intermediate phase quality control check of the part. So meaning that before we run the complete serial production of the parts in many quantities, we do the first check and then the last check, or also in between. So we can see whether everything is adjusted according to the process and in order to get the part which is according to the control drawing. This is the main focus. And in order to do the scanning, of course, we need to first do the CAD model and then write or make a program which then programs the camera to go around and check all the critical areas of the product.
So maybe there's a cast part, like on a corner, there's a cast piece. Maybe you'll check only that piece here before it might have been taken to production and then welded.
It can be, but in the measuring department, we have also that kind of camera where we can do also single pieces. You know, this is more or less for the complex parts with the aim of getting the quality control check done quickly.
Okay.
So in the case of single parts, you know, we can do it in the other location where for this part is also faster. Right.
Okay, the foundry process starts when we get a 3D model of research and development or outside customer. This 3D model we need in computer enlarge. We need to make in-gate system, a simulation, and later on we make a tool for injecting the wax on. So when the wax is injected, this is our model, then the wax we glue it on the cluster. When this is ready, later on we start to applying ceramic layer by layer. Wax is still inside. Ceramic is finished. We melted the wax, and here is empty hole. And then we prepare a titanium and cast the titanium into this hole. This is simply investment casting process. Some parts are quite complex, and we use our internal technological scrap for melting and pouring.
Okay.
So that means that we take the technological scrap from laser cutting from pipe production, we get it back here, we shred it, clean it, and make briquettes. And this is now our incoming material for melting unit. So somehow recycling.
Okay.
Yeah. For this reason was also made the foundry to recycle.
It's like a circular process. You try to
Yeah.
use as much
Yeah.
as you can in different places.
Not everything, but as
Yeah.
much as possible. Where we cannot produce a tool, racing prototypes, we make a 3D printing model, and then we working on the same way and cast it. This is much faster than classical production with the tool and everything. And we use them for a prototype. The geometry is not fixed yet, or for a racing application where they changes each 14 days some new, make no sense to produce a tool. Why we cannot print the titanium? Because of the powder.
Okay.
There is many powders on the market, but not resisting to higher temperature.
Gotcha.
We have our own titanium melts, which with the titanium which is resistant to higher temperature. This is the reason why we use printing of the wax and then casting instead of direct printing.
Welcome to the Akrapovič testing facility. We are here at the chassis motorcycle dyno. Basically the same as any other dyno in the world, but we don't only perform power tests over here, we also perform noise measurements, we also perform emission measurements. So we basically develop the whole exhaust system from the beginning, from the prototypes to the end, over on this dyno. So it's pretty important position in our company. We basically start with developing with prototypes. Well, depends on the complexity of the configuration of the prototype. How long does it take to build it to the end? So if it's a simple one, let's say 1 month. If it's a more complex one, maybe half a year, even longer. So it depends on the configuration complexity. We develop ECE type approval exhaust systems, but also we do also track day solutions for some customers who want to ride only on racetracks. As you can see, there's not only one dyno, there's two, because I already mentioned we also do emission tests, and the second valve is for the emission testing because it's different hardware. So we have our own certified emission laboratory that uses different hardware for the emission test. We need to do the stock measurements first because we are always comparing to the stock exhaust system.
So that's your baseline.
So that's our basis. So for further development, we need to be, our goal is to be basically more powerful, better sound, less weight, better design, better quality than the stock exhaust system. So these 5 performance
Pillars, key pillars. But do you prioritize one over the other? Like what would be like number one, like lighter, more powerful, better sound? Like what would be the number one?
Number one would be performance. Then the sound is also very important. So it's basically the first thing that the driver hears is the sound. So the performance is
you feel here and
something you feel if you're good enough, you know what I mean?
Yeah.
But the sound is what everybody hears, not just the driver, also the audience. So.
Well, can you explain the difference between if you're developing a system for aftermarket, which has to pass, emissions, ECE, versus a track day exhaust, as far as like the decibels or as far as the differences in that?
For the ECE approved exhaust system, yeah, of course we have to align with all the regulations that are in place. So the noise, the emission levels, as already mentioned. But for the track day solutions, we also have dB limits, but they're higher. More and more racetracks around the world are getting those limitations. We know about them, and we need to be under the limits, of course. The point is that because the limitations are higher, also the power is higher.
What's the most popular bike that you work on?
Well, lately the most popular, I would say, of course, the GS. We don't just develop exhaust system for that bike, but we also develop a little products that are not based only the exhaust system. So we also we are developing protection bars. So yeah, it will be presented shortly to the audience. So yeah, we recognize the bikes that are popular, and we try to diversify our products.
So is any of the motorsport, like MotoGP bikes and stuff, done here?
No.
Different department?
That's a different department. That's the racing department across the street.
Gotcha.
Yeah. So over there, they focus on MotoGP and Superbike. And,
I just want to differentiate that, because if you're doing aftermarket for street and aftermarket for track day, it's different from pro racing and motorsport in some ways.
To simplify, over here we have serial production bikes, but we do ECE type approval and track day versions.
Gotcha.
But over there, they only work with racing bikes.
Racing bikes.
Yeah.
Gotcha.
Yeah, so that's the main difference.
Okay.
Perfect. Thank you.
Welcome to the racing department of Akrapovič. This is where we deal with all the racing activities inside the motorcycle sport, I would say, from many different categories, let's say from the top down MotoGP, World Superbike, MXGP, Rally, all the way to MX2, Enduro World Series, and also some lower categories like Super Sport that supports the World Superbike, let's say Enduro lower levels from the startup. We basically cover the world level, and let's say national levels are covered by importers or dealers itself. This is where we organized. We are a 18 people team, mostly engineers, technologists, and like this, and also a few people that work with logistics, with sales, with sponsorship contracts, and so on. Of course, also testing here in our dyno room. What we also take care of is support on the races itself. We travel to a few races of the each championship each year to gather the information, to gather the plans for further development, future development. Yeah, this is our basic scope of work.
Yeah.
We, let's say, outsource the assembly, the actual production of exhaust to other department in the company. So we use some parts of the production. I don't know if you have seen, but mostly all the racing products are produced here in this location in Ivančna Gorica, just through that gray door out there.
Percentage-wise, how much do you work with direct manufacturers for the bikes and then the race team? So like input from the team and input from the manufacturer of the bike to make something for the World Series?
I would say more than 90% is directly from manufacturers.
Okay.
Because manufacturers are involved with development of the bike, and then teams just, let's say, logistically handle the operations of the racing activities from the scene to the scene. Teams itself give some input, but this depends on some teams are proper factory teams, some teams are outsourced from the factory, and then differs the involvement of the teams itself.
When the manufacturer sends the bike to you, will it come with their version of the exhaust that they've designed with the bike, or will it sometimes come without an exhaust at all?
Depends on the cooperation, also on how fresh the bike is. If the bike is fresh to the market, let's say when the racing series is based on the production bike, we may start with the stock exhaust that goes then to the street, and we of course optimize, manage differently. When it comes to the GP, if there's a fresh project, there is no exhaust. We get the 3D model, sometimes the bike, we prepare the propositions, and then we manage them together with the OEM, the manufacturer. Once they confirm, we go ahead with production, prototypes, testing, and then production.
And for the road bikes and customer bikes, we talked about that the other workshop basically, but they prioritize sound and then performance, or maybe equal sometimes. Do you prioritize performance here versus sound, or does it kind of flip?
Yeah, performance is top priority.
Okay.
Many times overlooked is durability.
Durability. So
You won't win if you don't finish the race. Okay, this is more important also in endurance racing, but anything else is durability is also high on priority list.
So can you talk about any of the materials that may not be available to the, like the public, the street motorcycles that you guys would use for the motorsport applications?
Base material is the same that you can buy. Is titanium in different grades that is also used on our products that you can buy. Then maybe some special coatings are not available so general. Let's say on the joint parts, we use special coatings to prevent too much wear, so to increase the durability. Sometimes you even need to reach the basic life of exhaust. Otherwise, you may just have the life of exhaust, let's say 500 kilometers, which is unacceptable. We aim usually to around 2,500, 3,000. This is our ballpark where we want to be.
3,000 kilometers.
Kilometers, correct.
That was my next question. How long, when you produce a motorsport product, how long is it supposed to last for that? Does it depend on the series, like MotoGP, it needs to last 3 races?
Depends a little bit on the series. Let's say for the sprint races like MotoGP, World Superbike, we would set about 2,500, 3,000 kilometers. For endurance racing, where you have a 24-hour race, they highly appreciate if they can do 24 hours with one exhaust. And this could be between 4,000 and 6,000 kilometers. Depends on the race, on the pace, on the weather, and so on. For motocross, for MXGP, they count hours more or less, not kilometers. So the exhaust there needs to survive between 20 to 30 hours, and then it is shifted or rotated to the test team, to the test bike, training bike, and so on. So it lives much longer. For, let's say, rally, Dakar race, you have a 2-week race with 400, 600 kilometers per day. So there's many miles, many kilometers done. They are also happy if they can do with one exhaust. Okay, in case of a crash, of course, they change. But it's good for them to get exhaust out of the head if they can rely on it.
how many iterations of one exhaust do you do during a MotoGP season? How often do they come to you to iterate on the exhaust?
Let's say the ballpark would be 2 to 3 times per year.
Okay.
On the other series, it's more stable. It's like for 1 year, it's one specification. Maybe small changes for durabilities and clearance here and there, but generally would say 1 generation per year. Let's say typical MotoGP team with 2 riders would consume between 25 and 40 exhausts per year. But this also means that inside this quantity will be at least 1 generation change.
What's the life cycle? Like when do you start and when do you finish the product? Like 6 months, 12 months?
Now the lead time is actually quite shorter on this. Okay. It's between 8 to 10 weeks.
Okay,
depends on the...
And that's production, 8 to 10 weeks? Is there like...
From the cut model to the...
So from the design phase all the way to...
First prototype, so let's say first specimens that they're able to use on the track.
But when you start the design phase, how far back you start the design phase of a new exhaust for MotoGP, for example? Like, is it a year before, 6 months before?
Before they start on the actual races.
Exactly.
This happens between 6 to 8 months before.
Gotcha, okay.
But this also depends on their schedule, on their testing schedule. They also have, let's say, a production schedule of the other components. So we will start more or less now for next year.
Perfect, thank you. Appreciate it.
Welcome, this is our durability test bench. We call it MDD, which stands for Motorcycle Durability Dyno. And here we test our motorcycles, our products to the limits. As the name of the test bench tell us, this is actually, we try to find where it's the life expectancy of our exhaust systems. And we push our products to the limits. And with that, also our motorcycles. And for that, we have this nice robot called Sabrina, made of steel, runs on compressed air and electricity. She is very gentle with the bikes, but all the brains with our guys controlling it. Here we run 24/7 tests, so we do up to 10,000 kilometers of really harsh driving. We do everything, shifting and everything. So what is interesting, we develop her hand for the throttle. It's smart device, so we try to test all aspects of using our products in real life. So
When you're doing a durability test for 24
Yeah.
hours, how do you fuel the bike when you're running for 24 hours?
for that, for short test, the fuel in the tank is enough, but for long runs we have that special system which fits the motorcycle directly. So a lot of safety systems, we have hot parts, and it's very dangerous, so you need all that. The tire has to be a special one suited for the roller. The main issue is our products, how they are performing. So we do a lot of intermediate checks. We measure back pressure, we measure temperatures on many points, so we see how it's changing with the use.
And then once you do a durability test, you'll maybe remove the exhaust, and then they'll inspect it
Yeah.
all and take it apart and see all the layers.
Yeah, you must understand those tests are called harsh, they are accelerated. So 10,000 kilometers here, it's maybe 100,000 kilometers on the road. So we have, the blower which can blow the wind with 250 kilometers. So it's a really strong acceleration and braking and so on. So you usually don't have that in real life. And in such intensity. For some motorcycles, we have locked, like driving on a racetrack, and we replicate. And after the test is finished, our products are disassembled, and we check what is with material, how the temperature affected structure or our damping. So what we want to be sure that our product will last.
And it also isn't affecting like materials on the bike, like the
Yeah,
plastics
for
and the
definitely.
metal.
The problem is usually if we have side boxes, or so we see how much heat goes to the other parts. So we have to check a lot of parameters to be sure that product is compliant.
Let's see in action right now. I
Okay.
guess.
Forward.
All right, Mate, so tell me what we're looking at here as far as Akrapovič components. So clearly we can see the pipes, but then of course you also have this diffusing carbon fibers. Maybe we start with this and then we kind of transition towards the exhaust system.
Okay, on let's say many of the vehicles, we not only offer the exhaust system but also the optional parts, and these are in many cases the carbon fiber parts, and this is a carbon fiber diffuser that we are looking at. But we offer for some cars, some vehicles, also the rear rings, then the mirror caps, and some other carbon fiber parts. But what we are looking now at on this XXM car, it's actually an LCI version of it. It's the Akrapovič titanium EC type approved slip-on system, exhaust system, with a combination of titanium and carbon fiber manufactured tips, which reflects also our quality and our knowledge on manufacturing and dealing with titanium exhaust systems. It has also the valves integrated in the exhaust. But the main focus here was to check on this vehicle, because of the facelift version, the functionality of the exhaust, and we changed some of the things. Also the electronics was adapted, and some of the optional parts were modified. On some projects also we offer some additional parts, more or less track used parts, but it depends again on the vehicle, on the markets that we want to focus on, kind of really related with the demands that we actually get from sales from the beginning.
So I'm a newbie in the manufacturing process of exhaust, and I'm learning, a lot today basically. But if you were to explain to someone that's just like me, what is the benefit of having a titanium pipe but then also having a carbon fiber on top of it? Is it purely aesthetics, or there is an improvement in sound or durability as well?
I mean, we need to segment somehow this, Okay, obviously visual appearance, because we use only the, let's say, high prestige material like titanium, which is half of the weight of stainless steel. This is the first benefit. Okay, it doesn't corrode. That's also one big benefit. And with the carbon fiber, it's actually a prestige combination. We also have an internal design that we design our products in line with also, Akrapovič visual appearance. But on the other hand, there's also a technical benefit of somehow protecting the carbon fiber from high temperatures. That's why we also take care of this. Although we have many types of carbon fiber and also resins that we combine together, for most appealing version, which is visually more acceptable or better looking.
Yeah, nicer.
At least nicer, yeah. Then we need to protect it somehow from the exhaust flow blowing directly to them. So it's actually functionality versus appearance.
Gotcha.
So we need to combine this in a good package. So more or less, it's depending also on the design of the car. You know, how to design it,
Sure.
how to position it, what's the shape, you know, how to integrate everything inside. But on the other hand, the functionality of the part, or also the tailpipe is, or the tips, is to, in some cases, enhance the sound on the outside and also on the inside sometimes. So it depends on the project itself or the vehicle itself, if we want to reflect it to the cabin or not, or reflect it outside, but still we need to retain the noise limitations that we get from the noise standards. We are always trying to find a good compromise between the design functionality and the rest. And I think that, well, on the G82, 880, or, you know, I think we did a pretty good job. Yeah. So now we are in our chassis dyno room. So here we test the performance of our exhausts. What we virtually do is compare our exhaust system compared to the best version of the original exhaust. We do the comparison tests, so we can see also what we've done. Of course, we want to be better in all aspects, but we don't only measure the power, but also the torque, air-fuel ratio, back pressure, in some cases temperatures, and also we do the vibrational tests if, let's say, the complexity of the exhaust demands us to do that. What we take care is the safety first, but we can test here the cars above 1000 horsepower. It's a four-wheel dyno, so we can test the front wheel, rear wheel, all-wheel drive, whatever. So we have also the wind blowing up to 150 kilometers per hour. We have also some of the blowers here that can cool the turbines, the intercoolers, whatever we want, depending on the application. And we just really take care of the conditions that we test at our exhaust compared to the original one. And we are not really into the final figures, but more or less the comparison, so how much we gain. Normally we prepare a few of the prototypes and then test them and compare them. And we also then do the prioritization of those, also having in mind what kind of NVH have we achieved earlier on. This is where we decide also then, you know, in which direction we should go forward or confirm what we do here.
Part of this process and the intercooler parts that you have, the fans and the cooling, is to make sure that the conditions are the same from when you test OEM versus Akrapovič.
Exactly. We just want to make sure that we stand just behind our figures. Otherwise, you know, if we are not certain on that, you know, we can have some of the claims, you know, from, you know, the outside that we didn't maybe do a correct measurement and so on. So we want to be really precise with that. Okay. Although we have a testing facility, a testing track, so to speak, near the company, where we do the real driving testing. And there we test with the microphones and so all the setup, also to, let's say, comply with the noise emission standards. And this is done, let's say we can prepare the car, the vehicle, the exhaust system, and then the authorized, you know, person comes in person, right, to check. And then we do the test, and if everything is according to the regulation, we get a sign off. It's an easy type approval, you know, it's really demanding for certain cars. It's getting more and more demanding, right? Especially with the regulation changing, and with, let's say, additional sound emission provisions. This is 1/3 of the test which we do, can be quite tricky, right, to obtain. But this is where we are also good at, we excel at. So how we do the configurations, how we put them together in a good package, you know, in order to fulfill, in one hand, you know, the regulations, and on the other hand, the experience, you know, when changing the exhaust. And obviously the customers need to see and feel the difference.
So when you speak about noise regulations, how do you deal with compliance around the world? Because I guess Germany is more stringent than the US, for example. Do you build a single type of product at the lowest legal level, or do you build different products for different markets?
It depends on the application.
Okay.
So let's say if there's a focus on certain market, then we do only that.
Okay.
Right? But on the other hand, if we fulfill the R5103, which is in most cases satisfactory, then we do it like this. But it depends on the, let's say, product. You know, initially, that's what I mentioned. When we start the project, we need to have this information available because all the actions depends on that. So it's more or less specific. We don't like doing, you know, the let's say one configuration for all the regulations. That would mean that we need to do a compromise, right? This is not exactly what we want. It depends actually on the initial requirements. So behind us is the C63 IMG. So it's fitted with our titanium prototype. It's not the final one yet, but we are going to run it now quickly to see, you know, how it performs.
That's good. Awesome.